It's 1986, and for your birthday, you got a 1351 mouse. Most likely you're using the mouse with a GEOS operating system, which was awesome. It included a word processor, paint program, and a desktop. Just so much cool stuff, and it really made the Commodore 64 feel like a Mac almost. It was just great. And then later on, you're probably thinking to yourself, man, I would love to be able to use this in my own programs. Well, in this video, I'm going to show you how to integrate the mouse into your own basic programs on a Commodore 64. If you're going to follow along, feel free to look at the GitHub link in the description below, where you can download the D64 images of everything I'm going to show you in this video. So you can either follow along and program along with the video, or you can go right to the end result and try it out yourself and tinker with it. So what we're going to start with is looking at the disk that came with the mouse, the demo disk. There's a whole bunch of really good software on there. So let's take a look and see what's on the disk. The second file on a disk is COM1351, and it's a USR type file. That is a driver for the GEOS operating system. When you load the startup program, you're going to get a menu of 4 items and an option to quit. The first item is a simple mouse driver, and it is composed of these 4 files. The first one's the basic program, which loads in the driver, which is the bin program. And then there's the source, which is the source code for the driver itself in assembly language. The sprite data for the pointer is in mouse.pointer. This particular driver only works on joystick port 1. And it's almost useless because when you have the mouse plugged into joystick 1 and you start pressing the left and right mouse buttons, it will sometimes emit keystrokes to the keyboard and just be a real pain to try to figure out what's someone pressing space versus the left mouse click. So I would completely ignore that. Luckily, they give you the better mouse driver. It kind of begs the question, why even have the simple one if the better one is just that much better? But you have the better mouse driver. And those are the 3 files that start with M1351. And just like the other driver, there's a simple basic program, there's the actual driver itself, and then there's the source code in assembly language for the driver. The third item is called Example from the Manual, and that's the program Data64. That program is basically a combination of Mouse64 base and Mouse64.bin, but instead of loading the driver and the mouse pointer in from files, it's in a bunch of data statements. So when you run it, the program pauses, and then you basically get the Mouse64 program. And then the last item is the educational demo program, and that's Demo64. And that is an example program that demonstrates how to write code for the mouse that works by using simple sprite collision to detect when things are clicked on. The rest of the software is the 128 version of the 64 software that we just talked about. So let's write a quick program now that will put the mouse pointer on the screen. And believe it or not, it's only going to take about 5 lines of code. The first we need to do is load the driver into memory. So we load 1351.64.bin, 8,1. This is going to load a program that's about 250-ish bytes long into memory just 49,152. We're going to type new to start a new program. When we eventually transfer control to that program, it's going to install an IRQ handler, which is a piece of code that runs in the background that 60 times a second keeps track of the position of the mouse and how it's moving, and then translates it into the X Y coordinates of Sprite 0. And then all we have to do then is turn on Sprite 0, and at that point, the user should be able to move the mouse around the screen. So let's do that. So we're going to start line 50,000. This is going to represent a subroutine called enable mouse. And eventually we're going to go sub this to get the mouse started for our program. So at 5100, we're going to poke 2040, 56. So 2040 is an interesting place in memory. It's a pointer for the VIC chip to look for in memory the definition of Sprite 0. The sprites are stored in 64-bit slots starting at memory just 0 and all the way up to 16K. So 56 times 64, if we were to print that out, is memory address 3584. We'll come back to that in a few moments, but just know that that's where the definition for the sprite shape is going to be. So the next line of code is to turn the sprite on and make it visible to the screen. And we just poke 53,269,1 to do that. That memory address is an 8-bit value where each bit controls whether one of the 8 sprites is displayed. We're turning on sprite 0, so all we have to do is set the 0 bit to 1. And to add some color to it, we're going to poke 5327 with 7. That memory address controls the color of sprite 0, and the 7 is yellow. And then lastly, we're going to sys 49155. 49152 is the main entry point to install the IRQ handler. However, that installs it on joystick port 1. If you sys 49155, it installs in port 2. Let's run our program and see what happens. We have a mouse. Now we didn't load any sprite definition in, so what we are seeing is whatever garbage is in at memory just 3584, but we do have now a functioning mouse pointer. So this is pretty cool. So what if we want to get a mouse pointer? How do we do that? Well, they give you a program called mouse pointer on a disk, and that program is literally just the shape of the memory. It's a 64-byte program with a 2-byte header, which of course the header is memory just 3584. So let's load this and see what happens. Because we loaded it right into memory, our mouse pointer is now an arrow. So now we truly have a mouse pointer. This is pretty cool. So let's press run, stop, restore to kind of get things back to normal. And let's save a copy of our program onto a blank floppy disk. And we're going to save this as mouse. So at this point, a user would have to load our driver, (8,1), our pointer, (8,1), and then our program to run it. That's obviously not a great user experience. So what we want to do is write a piece of code that's going to detect if those items are loaded into memory, and if they're not, load them from disk. So if we take a look at the memory addresses 49,152 and 49,153, we see a 76 and a 9. So if we see those, we can make an assumption that the driver is loaded. And we can do the same thing for the pointer shape, 3584, 3585, and that's 240 and 0. So let's take a look at a program and see how we can incorporate that. So let's insert a line at 50,010, and we could say if 49,152 is not 76, okay, or peak 49,153 is not 9, well then load the driver in. We can do the same thing for the sprite shape. If 3584 is not 248, or if 3585 is not 0, well then load the mouse pointer in. And the way it would flow is if the driver is not loaded to memory, it loads it. The load command triggers the program to restart. Now it's in memory, so it skips to 50,020. Checks to see if the driver is in memory. It's not, it loads it, program restarts. Then since both are in memory, it skips down to our program and it runs our program. So let's save a copy of this to mouse. And then let's restart our computer and give this a try. So just a moment ago, I also copied onto our blank disk the driver and the pointer. So now let's take a look and see how mouse works. It should load the driver and then the pointer and then initialize the driver and show the pointer on the screen. And there it is. Excellent. We're off to a really good start here. So I'm going to press run, stop, restore to unhook the mouse driver from memory. And we need to take care of a problem before it becomes a problem. That mouse pointer is sitting in a really bad position in memory, 3584. That is right above basic. And if we write just a little bit more code, eventually we're going to start corrupting that pointer with our basic program. So we need to move that to a different area of memory. So what we're going to do is we're going to restart our computer to do this task. And we're going to load this mouse pointer into memory. And we're going to write a real quick program here to write it back to a new file called pointer2. And we do (p), (w) to create a program for it. We're going to write into the first character a 64, and then the second character is going to be a 3. That is the memory address of 832 in low-high order. If you're not familiar with the math, not that important for the moment. We're going to follow that by writing 63 bytes of sprite data out. And we're going to write it by peeking the file that we write in at 3584 and write it out to the file. So it becomes at 832. And then at 40, we're going to close 1. So running this program will create a file for us called pointer2 with the mouse data at a new memory location. So let's incorporate this now into our basic program. So now we just need to make a small modification to our mouse program. So let's load that back in. And we just got to change a couple things. Our mouse pointer is now at memory address 832 and 833, so we need to check those for those values. And then instead of mouse.pointer, it is called pointer2. So now we just need to change the VIC chip from looking at slot 56 to slot 13. And why slot 13? Well, 13 times 64 is 832, which is where our new sprite shape is. So let's run this. And if all goes well, we now have our mouse pointer at a different memory address. This is a much safer spot to have it and will cause us far less problems. So let's save a copy of this at mouse. And I'm going to press run, stop, restore. So now let's put into place some code to make an actual program. So we'll start from the very beginning, and it will go sub 50,000 to initialize the mouse driver. Then we'll set the border and the screen to black, 53,281. And then we'll clear the screen with Shift Clear and Control 2, make the color white. Excellent. We're going to add a piece of code here, 49999 to end. This way our program doesn't leak into our subroutines or at the bottom. And now let's work on that subroutine for a little bit. What we noticed before is when we started our program, the mouse sometimes appeared off screen and I had to move it on screen. So we're going to force the mouse on screen by setting the X and Y value of Sprite 0 to 100. So for Y, it's pretty straightforward. Y is the value between 0 and 200. That fits within a byte, not a problem. The X value of a sprite goes from 0 to 319. So the problem is that it doesn't fit into a byte. Bytes only contain values up to 255. So the way that you set the 9th bit that's required to completely set the X value for a sprite is by using memory address 53264. That contains a 9th bit of the X position for all of the sprites. So we're just going to set them all to 0. And that way our mouse pointer will appear at 100, 100 when our program starts. And then we'll just add a return here. So if we list our program now, we go grab the mouse driver, we get the screen ready, we print white, and then the program ends. So if I run this, our mouse is immediately on the screen, and I can immediately move it. So now we're starting to look like a program. So let's reset the mouse driver here. So let's add some code that will display the X and Y coordinates of the mouse as we move it around the screen. So let's start by grabbing the Y position of the mouse. So we'll make a variable called SY for sprite Y, and we'll just grab the value out of memory address 249. Grabbing the X value is a little bit more tricky. We need to grab the value out of memory address 53248. That part's easy. That's the first 8 bits, or you could say the lower 8 bits of the X coordinate. And to grab the 9th bit and convert it into a number, we're going to look at memory address 53264 that has all the 9th bits for each sprite in one 8-bit value. We're going to mask out just the 0 bit by ANDing it with 1. So that's going to become a 1 or a 0. And we'll multiply that by 256. That will give us the X position. So let's display that on the screen. So we'll add a line here on 200. We'll do home space X. We'll show the value SX. We'll just press left and a space. That way, when a number goes between 1, 2, and 3 digits, it formats correctly. I'm going to put the Y value out there. Left, and then we'll do, I don't know, 1, 2, 3, 4, 5. And then we'll put a semicolon, because we're going to add something to this line in a few moments. At line 290, we'll just go to 100 to create a loop. So as we move the mouse around, we'll grab the values out of memory, and we'll display it on top of the screen. Let's see how this looks. All right, 100, 100. And then as we move the mouse around, we can see the coordinates updating. Now there's one small minor issue with this, and let me change the border color to highlight it. So we're going to make the border color 11 instead of black. So we'll just do this. And then let's run this again. The problem you'll notice is if I move my mouse too far to the left, the number is 24. If I keep going, it goes behind the border. And if I move the Y position to the very top, the lowest visible number is 50. Well, we want to have it display 0, 0 for when the mouse is right here. So we need to subtract 24 from X and 50 from Y. So let's add that code in real quick. So here's the Y position. We're just going to subtract 50 off of it. And then here's the X position, where we will just add a little subtract 24 to it. Now when we run our code, the mouse appears at 0, 0 at the very top left corner. If you move it all the way over here, as we hoped, it would be 319, 0. And if we move to the very bottom right, it's 319, 189. So this is looking pretty good. So let's stop the program here. Now that we have the X and Y in pixels, it would be actually really useful if we had it for the character positions on the screen, where 0, 0 would be my cursor's here, X is 1, Y is 0 will be here, like that. That would be really useful. So luckily for us, that transformation is pretty easy. All we need to do is divide the Y or the X by 8 to get that value. So at line 120, we'll make a new variable CY, and we'll call that character Y. And we're going to call the integer function, and we're going to take the y position and divide it by 8. And then line 130, we're going to do the same thing for x. We're going to divide x by 8 and run it through the integer function. And then we'll add a line at 210 that will print it. So we'll say cx, go left space, cy, left space, semicolon. Cool, let's see what this does. Now we can see the character x and y move with the mouse. So here's 0, 0. If I move my mouse all the way over, 39, 0. And this should be 39, 24. So now we have the pixel position and the character position. This is going to be really useful. So let's reset here and just save a copy of our code. So we'll save it and we'll call it mouse. Okay, so we're going to augment our program a little bit more. I just noticed that XC should be CX, and I believe if we move our mouse around just the right way, we can get some artifacts left behind. So we're going to fix those two bugs, but we'll fix those in a moment. Let's talk about the next piece of logic we want to add in. Oops, there it is, there's the artifact. So we're going to hit run stop here. So what I want to create is two options in our program, say option 1 and option 2. And then as we move the mouse around the screen, have option 1 highlight when it moves on top of 2 highlights, and when it moves away from them, none of them highlight. That'll be kind of a nice typical user experience with a mouse. So let's do a couple quick things. Let's fix this typo that XC should read CX. And then we just need to add some spaces here to get rid of those artifacts at the end. All right, so with that out of the way, let's move this mouse off the screen. That's a little distracting. So what we'll do is we're going to write the code here to track the option. And the way it's going to work is we're going to create a variable called OP, and we're going to assign it to 0. That's going to represent no options have a mouse hovering over it. Then we're going to write some code here to detect if it's hovering over option 1. So if character line is 2, and the x is greater than or equal to 1, and x is less than or equal to 8, then option is 1. Pretty straightforward. And then we'll do the same thing for option 2. Except of course the difference is it'll just be the next line down, and less than or equal to 8, then OP equals 2. And then we'll go subroutine. I'm going to write in a couple seconds 10,000. Cool. So what's 10,000 going to do? It's just going to print the word option 1 and option 2 and highlight it if one of them has the mouse over it. So we'll start with 10,000, and we'll do a home down 10,010. We'll say if option is 1, then print reverse on option 1 reverse off 10,020. We'll say if it's not 1, then print space option 1. Pretty straightforward. And then of course for 10, 30, and 40, the same logic for option 2. And then we'll just end off with a return. So let's take a look at our program here just to review it. All right. So in our main loop, we're going to set option to 0. It means nothing's highlighted. We'll detect if it's over 1 or 2, and we'll set the variable OP accordingly. We'll go sub 10,000 to reprint that screen. I can't stress enough how this code is not optimized for speed. BASIC is really slow. But this is really just to show you how simple the code can be to introduce mouse usage into your program. So let's give this a run and see how well this works. So as you can see, my mouse is on the screen. We can move this around. And if I hover over option 1, it highlights option 1. If we move it over option 2, we highlight option 2. And if we move it away, both options are unhighlighted. All right, we're moving right along here. Let's save this up and let's move on to the next task. So the last piece of the puzzle is reading the left and right mouse buttons. And this is a pretty simple task to do. All we need to do is read the value at address 56320 and react to it. Well, we just need to know what values to react to. So to do this, we're going to write a really short loop, a one-liner. That's just going to go home, and then it's going to print the value of 56320, and then it's going to go to 60,000. All right. So if we run our program, and we'll just hit run stop because we want to have the mouse driver running, right? So we have the mouse working, and then we're just going to say go to 60,000. So now we can see 127, nothing is happening. So what happens when I press the left mouse button? We get a 111. Cool. All right, so we're going to write that down. Left mouse button is 111. And if I press the right mouse button, we get a 126. Cool, so that's pretty straightforward. So we're just gonna leave that line of code in there because that might be useful for debugging later. And we're just gonna add a line of code right around 260, right after we refresh option 1 and 2. And all we're gonna say is BP, or button press, is peak 56320. So we're gonna read that value of the button out of memory. If the button pressed was 126, that's the right mouse button, we'll use that to end our program. So we will clear the screen, we'll write the word bye, and we'll just end. So right mouse button will get us out of the program. If you press the left mouse button, which remember was 111, well then we'll just print home 1, 2, 3, 4, 5, 6, 7, 8, and we'll say that option OP is selected. And that's just going to print what option is selected. So let's see how well this logic works. All right, so we have option 1. If I click it, I get option 1 is selected. If I click here on option 2 is selected. And if I hit right mouse button, the program ends. And that pretty much covers everything you need to know to use a mouse in your own basic programs. But what if the driver being located at 49152 doesn't work for you? Maybe you have a sound routine or a graphics routine that you're using that sits at that same memory address. Well, I'm going to show you next how to take the source code in assembly language for the driver, load it into Turbo Macro Pro, and reassemble it at a different memory location. This is going to be kind of neat. So let's go try that out. So what I've done is I've copied the source code to this disk. That's M1351.64.src. And again, that's the assembly language source code to our mouse driver. And I put a copy of Turbo Macro Pro on this disk. So let's load up Turbo Macro Pro and see what the source code looks like. And we start Turbo Macro Pro with sys32768. So let's first take a look at the source code. You use Command E, and when I say Command, it's the left arrow key. And then we'll just type in the file name here, m1351.64.src, and that's going to load the sequential file of text into Turbo Macro Pro, and it'll attempt to analyze and see if the source code can be assembled. So what happens is we see a whole lot of junk characters, and everything's red, which are errors, right? So there's a few problems with how the source code is stored in the format that's on a disk. One is you have these little eyes, right? And these little eyes are actually tab characters. They're character 9s. They're meant to be a number of spaces. The other problem is that the source code is stored in an 80 column format. And if I kind of look around, you could see that it splits it into 2 lines. And Turbo Macro Pro only has 40 character lines. So we could spend a lot of time cleaning this up. It'll take a bit. So we're just going to write a quick program to clean up what we can to get a much better start with this, because this is obviously not going to work really well. So we're going to write a really quick program in BASIC, and what it's going to do is it's going to open this file. It's going to replace all these eyes with spaces, so it looks like this. Thus the line will be good. And then we're going to remove all the comments, because there's just too much noise in the comments to be useful. So let's do that real quick, and then we'll come back into Turbo Macro Pro and then try to load it again. All right, so here's how the program's going to work. We're going to open the file on a drive, m1351.64.source. It's a sequential file. We're going to open it for read. And then we're going to open another file, file number 2 on drive 8 on channel 7. And we'll call this m1351.64.s sequential write. So we're going to open up the .src file. We're going to make some transformations to it and run it out to just .s. So we'll grab a character from the file and put it in $. If the drive status is not 0, meaning we've reached the end of the file, we'll jump to a future line at 100. If the ASCII value of the character read in is 9, which is that tab, we'll transform it to a space. Oops, this should be line 50, not 30. That would be bad. So that deals with the tab key. We need to deal with comments, and what we're going to do is we're going to have a variable called cm, which I'm going to call comment mode. If it's turned off, we're just going to read the character and write it to the output file. If it's turned on, we're just going to ignore everything from it. So one thing we have to be careful of is when we read a carriage return, that's what a 13 is, we're going to turn comment mode off. That's a new line. We're going to assume that the comment is not there anymore. If we read in a semicolon, then we'll turn comment mode on. And then we get to the logic of what we write out to the file. So if comment mode is off, right, we're not reading comments, we're going to print to the file the character $, and semicolon, so it doesn't output a character return. And then we're also going to print it to the screen so we can see our program working in real time. All right, and then in 90, we're just going to go back to line 30. So it goes into a loop. 100, that's the line we referenced in line 40, which means we're done. We're going to close file 1 and close file 2. And there it is, a program to transform our source code by ripping out all the comments and turning the tab keys into spaces. So let's run this and see how it works. Now, as you can see, BASIC is really, really slow while it's doing this work. But you can see our code is working. It's pulling out the comments and it's inserting spaces, and this should be much easier to bring to Turbo Macro Pro. So let's just fast forward in time until when this is done. All right, excellent. So now let's fire this up in Turbo Macro Pro and see how much better it looks. All right, then once again, we just type sys32768 to start Turbo Macro Pro. And let's see if our new file is easier to bring into Turbo Macro Pro. So we're going to use Command E, and again, that's the back arrow. And our file is m1351.64.s. This is the file that we transformed. So it starts us at the bottom of the file. We still have some red text, but it looks pretty manageable. Most of the code looks assemblable, meaning it's gray. And if we jump to the top, we can clearly see that we can easily work with this file. So let's start cleaning this up and get into a state where it can be assembled. I'm going to kind of cook through this next section pretty quickly, just showing you the steps that it takes to get this source code to work with Turbo Macro Pro. All right, let's get started. So let's delete some blank lines from the top here. The lines in red are errors. Turbo Macro Pro does not like dots in the label names, so we need to search and replace these out of here. So for the label CIA.ddr, we're going to replace that with CIA.ddr. We use Command R, and again, Command is the back arrow, and we're going to replace CIA.ddr with CIA.ddr. And then we press Command, then Y, and it replaces them all. Command up to jump back to the top, and we need to do some other mask changes. So we need to change a label called mirq.1, and we need to make that mirq1. And again, you can see the error here, so Command Y to change all of those. There's another one called mirq.2. I'm going to rename that to mirq2. Command Y to replace all those. There's one called install.1, and we'll make that install1. Replace all of those. Then we'll replace install.2 with install2. Get all those. And just 4 more to go. We're going to replace $10. You can have labels that start with numbers in Turbo Macro Pro. And we'll replace that with the phrase label 10. Okay, so we'll get all of those. Those will all be fixed up. Then we're going to replace $90 with a label 90. And we'll replace all of those. We're almost there. There's an $80. We're going to replace that with label 80. And we'll replace all of those. And last but not least, we're going to replace $50 with label 50. And we're going to hit yes to that and get all those changed. Another small change we need to make is this block code here. And I'm going to mark it with Command MS and Command ME to mark this block. The intent of this is to be at the very end of the program to set labels to the last 7 or 8 bytes of the driver to use for variable space. Turbo Macro Pro doesn't like it being before the origin is set here, so we're just going to move it to the bottom. So we're going to do Command down to go to the bottom, enter a few blank lines, and then use Command B for block, M to move, and we'll move that text down here. So now that should be fine. There's another couple small changes we need to make. There's a section called remove, so I'm going to search for the word remove. I'll use Command H to go to the next one. Here we go. So here, these are duplicate labels in TurboMacro Pro. So we're just going to put a Z at the end of it so they become global unique. And the very last we need to change is at the bottom of the label MIRQ1. Oops. Didn't mean to add a character return there. There's a label here that says label 90 that we just need to take out. So we're just going to remove this. Oopsie. There we go. And let's get rid of some of these blank lines that are here. All right, so now we have source code that should compile to a driver for us. So first we're going to save this. Because TurboMacro Pro saves to a program file, we can't overwrite the sequential file that we created. So we're going to call this version m1351.tmp for turbomacropro.s. And now we've got the source code that will assemble in TurboMacro Pro. All right, so now we're going to do a command 5. This is going to assemble it to disk. And we're going to call this m1351$C000. Okay, this gives us a driver that we had before at C00, except we assembled it ourselves with TurboMacro Pro. And then, of course, what we really want to do is create a driver at a different location. So a very easy way to test this is we'll just make a driver at 8000. So when you change the memory location of the driver, you want to change it here at the top to be, in this case, this will be on page 80. And then you want to jump to the bottom and make sure this is the equivalent page as the top of the source code is. So this is going to be on page 80 as well. Cool. So we're going to make this also command 5, except we'll call this M1351$8000. So now we have two different mouse drivers, one at 49152 and one at 32768 for us to choose from. And of course, you can do this yourself and make the driver at whatever memory address you want, because now we have the source code and we can build it. So let's try this out. Let's restart our computer. And let's load up our mouse, (8). And what we're going to do is we're going to drop in the driver that we just created to make sure that our driver works correctly. So instead of using mouse 1351.64.bin, we're going to use mouse $C000. So our program should run as is, except we're going to be using the driver that we assembled ourselves with TurboMacro Pro. So we'll give this a run. Oops, I obviously spelled this wrong. It's M1351$C000, my mistake. So we're going to run this again. And here we have our own driver. Now let's try it at the other memory address. So we're going to do a run, stop, restore. And we're going to do a listing here. And instead of the driver at C00, we're going to change it to 8000. Now there's a few things we need to change, because instead of it being at 49152, it's at 32768. So we need to change this to be 32768, 32769, right? And then we need to change the entry point here. So it's 32768 plus 3, so to be 71. Okay, so let's give this a run. And now we're using a mouse driver at a different memory address. So just a reminder that all of this code is available on the GitHub link in the description of the video below. So if you want to try it out yourself, go ahead and give it a shot. One interesting thing about this driver that I found really interesting is our version assembles to one block instead of two blocks. The version on the disk that they have has some padding at the end that causes it to be 255 bytes. With the 2-byte memory header, it causes it to be 2 blocks long. I did write a program to test byte by byte the two drivers to make sure they're exactly the same, and they are exactly the same. So I know the compilation is good. So a bonus point for using your new driver is it's actually one disk block shorter than the one that comes with the demo disk. Well, this video was an absolute ton of fun to put together. I didn't expect the demo disk to have so much amazingly great information on it, to be able to just make the mouse super easy to use in your own software. So that was really cool. And again, I just can't thank you guys all enough for watching these videos. Just so amazed with how many people are checking these out. And I'm really glad you like it. I have some more really cool stuff I'm working on, and I can't wait to show it to you all. Take care.